right, guys, so we are taking a look at notes for section 3.5. Our learning goal is that we can solve systems of nonlinear equations. We want to be able to solve these systems by three different methods. One is by graphing, one is going to be by substitution, and the last way we're going to do the solving is by elimination. So we've got these three methods that we can use. All right, so first of all, solve equations by graphing. To solve this equation where we want f of x to equal g of x, we can write as systems of two equations. And we can say y equals f of x, y equals g of x. We can graph these systems. The x value of each solution of the system is a solution of that equation. So here they're telling us that y equals this part right here, and y equals this. So we want to solve this system. We want to know what is the point that is going to make this a solution. All right, so let's go to our calculator and let's go to y equals. So we're going to put in 1/2 x squared minus 3. And we're going to put in -4 minus 2x squared. Make sure you're putting this in correctly. Like, you want to make sure that you put in a negative when you need to put in a negative, and that you're putting in subtraction when you want to do subtraction. You've got to be careful with that. All right, so now, do you guys remember how to find where these two are going to meet? Yep, so I'm going to have to graph them first. Notice I have a negative there, but subtraction there. So I'm going to go ahead and do a zoom 6. And for this equation, are these two ever having anything in common? No, so this has no solution. Now, I want to point out something. This answer is not that there's no real solution. There is no solution, period. Because what we're looking for in this case is we're looking for the point where these two intersect. And there is no point, whether it's real or imaginary. We say this is no solution. Okay? Let's go to the other one. So now I'm going to put this second one in. And again, we're trying to solve for the points of intersection. So we're going to graph it. So the first one is a parabola, and the second one is a line. Okay? We're trying to find out where that point is that they meet. So I'm going to do second trace calculate, that point of intersection. We're going to get over pretty close to it. And I'm going to push enter, enter, enter. Because what I was doing is I was choosing the blue one, the red one, and then their point of intersection. And so 2, 0 is going to be the solution to this problem. Okay? Make sense so far? All right, so here we're solving the system for both x and y. We're trying to solve what's x and what's y. So here's x, here's y. Okay, what about if we just look at this picture? If I give you a diagram, can you solve this system just by looking at the diagram? Sure. What's that point appear to be? Let's see. It's going by 2's, isn't it? So what's the x value there? -1 and what is it? 4, 6, 8, 10. -1, -10. And then the other one is going to be at 2. And then what's the y value have to be? -10. Okay, so there's that solution. And then what about this one? What would I say? Do I say no real solution or no solution? No solution. Period. All right. Solve the system by substitution. So we've talked about how we can solve the system by graphing, and now we're looking at how to solve the system by elimination or substitution. So can you see how it says y equals this? Well, that means that in this equation, wherever I have a y, I can replace that y with this. All right, look at it. Y equals this. Here's my first equation. So do I change the x squared? No. So it's going to be x squared plus, where I have this circle, I'm going to put in negative x plus 4. Then it has to get squared equals 16. Now, I noticed some of you on the quiz on that last problem, squaring this binomial, you didn't do that correctly, and then that messed up your answer. So I want to talk about how we square this. It's x squared plus, and then I have to write this out. I'll show you a shortcut. But here's what people would do. They would just do negative x squared and 4 squared. You can't do that. You have to write it out as a binomial. So we're going to have x squared plus, what's negative x times negative x? Positive x squared. Then I'm going to do my outers, negative 4x. My inners are negative 4x. Last times last is 16 equals 16. Let me pause for a minute and let you get caught up with that. Okay, so I've got 1x squared and 1x squared, that's 2x squared. I have negative 4x minus 4x, that's minus 8x. And then I have 16 equals 16. What's going to happen with those? What are they going to become? Just 0. So equals 0. How do we solve a problem like this? What do I do, Jacob? Good. So what is the GCF? 2x. Am I allowed to just divide by 2x? Can I divide the whole equation by 2x and just get rid of it? Nope, because there is an x. I could divide the whole thing by 2, but I cannot divide by an x. X is a variable. I'll lose an answer if I do it. So I'm going to just factor out the 2x. I'm not going to like completely get rid of it. So what's 2x squared divided by 2x? X minus, what's 8x divided by 2x? 4. Okay? So when I say divide it, I can divide them, but I'm just not going to divide and get rid of it. Okay, so now I've got two factors. So 2x equals 0, x minus 4 is 0. And so what is going to be the solution to this one then? Just 0. And what's the solution here? 4. Now, I'm not just going to say those are my answers because I'm trying to solve this system for x and y. You see what I mean? I'm trying to figure out what x is and what y is. So one of my solutions is 0, comma. My other is 4, comma. How do I find out what x is or y is for these x's? Sarah?
Plug x back into both.
Okay, which one do you want to do, top or bottom? Okay, so if you plug in 0, what are you going to get?
4.
Right, so 0, 4 is one of our solutions. And then what if we plug 4 into the bottom? What are we going to get? 0, right. And so those are going to be our two solutions. Okay, that's substitution. Got our two answers there. Let's take a look at our next method, elimination. Let's do 7 first. It's a little easier than 6 is. We want to solve this by elimination. Elimination means I want to eliminate either all of my x's or all of my y's. Which is going to be easier to eliminate, x's or y's? Y's. So how can I eliminate the y's? What can I multiply my second equation by? Negative 1. So I'm going to multiply this by a negative, this by a negative, this by a negative, and this by a negative. Every single one of those values had to get multiplied by a negative. And now we just add. So y minus y is going to be 0. 9x squared minus 1x squared is 8x squared. Positive 6x plus 8x is plus 14x. And 2 plus 19 is 21. All right. No mistakes there? Okay, so this is kind of difficult to factor. To find out if this can be factored, I would have to multiply 8 times 21 and see if there are numbers that multiply to be 8 times 21. So 168. Are there numbers that multiply to be 168 that add to be 14? I'm sure none of us really know that offhand. Let me show you how I'm going to figure this out though. So it's 21 times 8. 21 is 7 times 3, 8 is 4 times 2. I can use any combination here. What about 12 and 14? Will those add to give me 14? No, too big. What about 28 and 6? Maybe this can't be factored. It seems like it should be able to. I'm trying to, some other combinations just in my head here. So what can I do if I can't factor it? What can I use? Quadratic formula, right? Negative b plus or minus the square root of b squared minus 4 times a times c. What do you think might be happening here? No solution. I heard somebody whisper it. Okay? I couldn't factor it. I'm trying the quadratic formula. Before I go too far with the quadratic formula, I want to see what is 196 minus 4 times 8 times 21. There's the issue. So what does that mean when we get that negative when we try the quadratic formula? It's imaginary solutions, which if I'm trying to find as a point of intersection, then that doesn't mean I'm getting two imaginary solutions. What does it mean? No solution, period. Guys, I'll tell you, I remember on our test that you have a problem kind of like this, and a lot of people go through this whole concept and they give me the imaginary answers. And that's wrong. Because if I have y equals this and y equals that, that means I'm solving for x and y. There's no x and y that makes these both true, so there's no solution. If there's no point of intersection, there's no solution. Okay, on this one, solve this by elimination. Okay, watch what I'm going to do here. I want to get everything kind of lined up. So I'm going to have x squared minus 7x. I'm going to bring this y over, minus y plus 12 equals 0. See what I'm doing? Just getting everything over here. Let's see, what's this one going to be? I have negative x plus y plus 4 equals 0. Ah, great. Why do I say great? If I add these together, what's going to happen? Yeah, that's what I need to happen, so that's great. X squared minus 8x plus 16 equals 0. We can use that new wonderful quadratic formula we learned. We can use completing the square, but are there numbers that multiply to be 16 and add to be 8? What? 4 and 4, right? So I'm just going to factor it. Why waste my time with those other methods? 4 and 4, minus minus, x equals 4. Don't need to bother. I've got two solutions there, but they're both 4. That means that they just meet at this one spot. Plug in 4 for x. Negative 4 plus y equals negative 4. What's y going to be? 4, 0. Okay? All right, we're not going to do this one. I don't like it. I want to talk about this one now. So this one is something that I want to do instead of these two. It says solve this system by graphing. And the system we're going to solve is 2x squared minus 12x minus 16 equals negative 6x squared plus 60x minus 144. Now, I could, for this one, do I have a y value that I'm solving for? Is there any y in this problem? So I'm not solving this for x and y. I'm just solving this for x. Okay? But I can still use my calculator because I can plug this in for y1. So I'm going to put in 2x squared minus 12x minus 16. Into y sub 2, I'm going to put in negative 6x squared plus 60x minus 144. Make sure I got that in right. Okay, I'm going to do a zoom 6. Here's my first parabola. It should be opening up. Here's my second parabola. It should be opening down. Ooh. So my solutions are down here further. I'm going to have to do what with my window? How? What should I change? The y max or the y min? Yeah, I'm going to make this y min like negative 50. See what happens. Okay, there's the first one. There's the second one going to come in here. Okay, I'm trying to solve for x only, guys. There's no y in this problem. I do second trace, calculate the intersection. I get over here close to it. I do my enter, and here's my solution. And I'm just going to round this. They're going to have us round to the nearest, let me see what they have us round to. Nearest 100. What is this answer, rounded to the nearest 100? 2.44 is one of my solutions, approximately, or x is approximately, find the other one. Get over there close, enter, and how do I write this solution? .56, right. Do I want to put the y values with it? No. The reason I don't want to put the y values is there's no y in this problem. We're only solving for the x's. Do you see the difference? The other ones had y, this does not have y. These are my two solutions. All right, one more, real quick. Sum of two numbers is -5. I'm going to call x my first number, y my second number. How would I write that then? If the sum of these two is -5, what does sum mean? Add, subtract, multiply, divide? Add. X plus y is -5. What does product mean? Multiply. I'm seeing a lot of people put add on that. And the sum of the squares of the two numbers is 17. The sum of the squares of the two numbers. Well, here's my first number, squared. What's sum again? Add. My second number, there's how I write the sum of the squares, is 17. What do you think would be a good way to solve this? We have three methods: graphing, elimination, substitution. What do you think? What do you think? Substitution is really our only option. I can't eliminate because these aren't even like terms. Graphing, I would have to solve this for y, and it's y squared. That would be tough. So I'm going to just get y equals, what does y equal on the first one? Y is -5 minus x. So down here where I've got this y, I'm going to put in -5 minus x. I got to square it. I'm going to show you the shortcut on this one. So I have x squared plus, the shortcut way, rather than writing this out twice, is I square the first one, I multiply these two, and I'm going to get two of them. What do I get if I multiply these two and then double it? Plus 10x, and then square the negative x, and what do you get? Plus x squared. Look, guys, I just saved you some time so you don't have to do this. I'm going to do this quickly. -5 times -5. Outers gives me 5x. Inners gives me 5x. Last gives me x squared. See how it's the same thing? But this is a lot faster if you can just kind of memorize that method. 1x squared plus 1x squared is 2x squared plus 10x. I'm going to subtract the 17 and I'm going to get 8. How can I make this problem easier? What can I do to every single term, guys? I'm allowed to divide by 2, and I'm going to. Are there numbers that will multiply to be 4 and add to be 5? Okay, so we're going to have x plus 4, x plus 1. So one of my solutions then is negative 4. My other solution is negative 1. So I can say then that my first number could be negative 4, or my first number can be negative 1. You see what I mean? X is my first number. So my first number can either be negative 4 or my first number can be negative 1. What is my second number when my first number is negative 4? Negative 5 minus negative 4 is negative 1. Or I can plug in negative 1 here. If I have negative 5 minus negative 1, what's that going to be? Negative 4. You see what I mean? So the first number is either negative 4, second number is then negative 1, or it could have been vice versa. Is it true? Is the sum of these two numbers negative 5? What do I get if I square that? What if I square that? What's the sum of that? 17. Okay? All right. We are done with all the notes for 3.5. So that's good news because tonight, you need to make sure you do the